And welcome to the daily space weather. We've got some new large sunspots that just rose and formed in the eastern limb, some plasma instability, and plenty more to cover. So coronal hole high-speed stream on the wind. Coronal hole high-speed stream on the way. Showing up in the solar wind. This is the past 24 hours. That is SDO ionized helium plus ionized iron. And lots of features to talk about, so let's take a brief trip. Starting out with a zoom in at the equator. You may see a bunch of plasma filaments, a coronal hole there, just below and to the west of the Earth scale. Also several active regions. We have an increased likelihood of large solar flares both in the northwestern limb and the southeastern limb. Also, the northeastern limb has a new magnetically complex sunspot. We'll show in-depth analysis of that. Also, sunspot 3333 finally got named. So finally, everybody can claim that it's some sort of globalist conspiracy, the Illuminati, or some other nonsense like this. The number 33, because numbers in 2023 are also scary. Stars, galaxies, numbers, planets, gases, these things are all very, very scary. Numbers topping the list of scary things in 2023. So here's a close-up of this northeastern new sunspot, also a massive plasma filament ahead of it there. A little bit of instability happening there with that plasma filament. These groups in the southeastern limb. This is, I believe, the most likely place to see a major flare. Again, the southeastern and the northwestern solar limbs are the most likely places to see an M or even an X-class flare here at the moment. This new sunspot in the southeast, this one just above the Earth scale there, that is my favorite sunspot to produce major solar flares. We'll tell you why later in the video before we do our meteorology segment. Also, you can see this huge prominence here just east of the Earth scale there, which would be to your left. Huge prominentiary filament there. That could be our latest south solar polar vortex, depending on how that releases, if it releases. So that's another feature to keep an eye on. And when I say ion, well, pardon the pun, that is a huge filament indeed. We've got quite a lot of them. We'll take a catalog of those later in the video also. And by way of completeness, let's show the north polar region as well. Still a crown prominence up there also. So you can see some plasma there looking like it is indeed encircling the north solar polar region. Always an interesting thing indeed. And let's take a look at sunspots. Just a brief glimpse here. So this is yesterday plus today, and no, the sun didn't suddenly speed up its rotation like that and then slow back down. That's just missing data from the SDO. Let's just look at the final couple frames here. So we've had growth of sunspot 3333 and also these two new sunspot regions, at least two. It could be three new sunspot regions over here. It all depends on what's going on in this northeastern one, but this southeastern one is certainly large and quite complex. So there are the colorized magnetograms. Little uptick in solar activity, and we're going to take a look at what's going on Earth, but just a brief explanation of our paid promotion. Yeah, these videos, they include a paid promotion because, well, we're paid just this side of nothing to put the content on YouTube, so we had to look up all kinds of solutions to make some cash on these videos to increase the probability they'll continue to remain publicly visible and free for all to view. So we endorse certain products like the Hemp Lucid products. So if you're shopping at Hemp Lucid, please enter the promo code SMASHOMASH. That'll save you 10% on your checkout. The promo code SMASHOMASH. Yeah, the name of our channel and our website is the promo code on Hemp Lucid. So you can shop via our links. They are located in the description below this very video, as well as on our homepage at smashomash.com. Hemp Lucid. Enter the promo code SMASHOMASH. You'll save 10% on your checkout. We've also got an Amazon shop. Today's featured product is magnesium. Seems very basic. A lot of people have trouble sleeping, and some people are made drowsy with magnesium. So this also helps to protect your cellular health at nighttime while you're sleeping. We don't recommend taking it with calcium. Take it before bed. Try out magnesium. It may help you with your sleep. It's one of the many important minerals that many people are lacking in their diet. So check the Amazon shop for that. It's amazon.com/shop/smashomash. It's also linked below the video. All kinds of different idealists there, space fashion, and all various other items that we'll endorse. Next, looking at volcanoes, Shivaluch is continuing to erupt. It's producing a 12,000-foot plume of volcanic ash. Also, Abiko, a 10,000-foot ash plume there over Paramushir Island from Abiko. Suwanosejima, a 6,000-foot ash plume. 9,000-foot ash plume from Mount Mayan. So that's an uptick there at Mayan, as it's now producing an ash plume instead of just effusive eruptions. Mount Ibu also ground report of eruption with a volcanic ash cloud of 7,000 feet. Kilauea's been pretty stable here over the past 24 hours. It's a bit of a downtick there at Kilauea. So no significant growth of the lava lake, although there is still a minor effusive eruption happening there around the Halema Uma'u lava lake. Popocatépetl also exploding in central Mexico there. It's a 20,000-foot ash plume, flight level 200. Fuego, sporadic emissions of volcanic ash and mild explosive activity. No indication of an ash plume size there or at Nevado del Ruiz in Colombia. Possible volcanic ash emissions there. Sangay in Ecuador producing a 23,000-foot ash plume. Flight level 230. Flight level 140, 14,000-foot ash plume over Revenador, and a 20,000-foot ash plume over Sabancaya in Peru as it explodes. Please do not pole vault the caldera. Here's the past 90 days of seismic activity on planet Earth to give you a little summary there of what's been going on, and a little earthquake swarm here north of New Zealand in the past 24 hours. We'll cite the quakes that are of a 5 magnitude or greater. So there was a 5.4 in the Bismarck Sea, that's north of Australia there. And then we had, at 16:16 yesterday afternoon, we had a 5.3 out in the Aleutian Islands there. And then 44 minutes later, a series of quakes started to strike the Kermadec Islands region. We had a 5.3, a 5.4, 5.2, 5.3, and a 5.1. So these could all be foreshocks to a larger event, although so far the largest has been this 5.4 that occurred at 17:01 Universal Time yesterday afternoon. Since then, there have only been smaller quakes. So a great reminder there that any earthquake can be a foreshock. And did you know we send out email alerts for tsunamis on our smashomash.com/smash team list? Yeah, they regularly come out long before the USGS alerts come out. So smashomash.com/smash team, one of the many, many value-added features there. And those are the quakes of a 5 magnitude or higher. And welcome back to space. Here is the past 24 hours from SDO and ionized helium, 304 angstroms. That's pretty sweet imagery, right? How about if we add 171 angstroms to it? That's ionized iron. And welcome to the world of the living, Smash staff. All right, so let's take a look at some stats here. The 10.7 centimeter radio flux is only at 146 solar flux units. You can expect a big uptick in that today. We've also seen the X-ray profile come up, which we will show you here as well. There's the 1-year graph of the radio flux represented by the black line. The sunspot number is the red line. You can expect the sunspot number and the radio flux number to come up by the time tomorrow's daily space weather video comes out. We've got a minor uptick here forecasted here by NOAA. So there you go. There's the coronal hole high-speed stream showing up. They're expecting it to show up late in the day tomorrow. I'm expecting the high-density portion to show up a little bit earlier than that. I'm expecting the high-density portion to show up probably by the time we make tomorrow's video. So coronal hole high-speed stream on the way. That is the Space Weather Enthusiasts dashboard if you want to look into that yourself. It's one of the many dashboards available at the Space Weather Prediction Center. These are NOAA's forecasts, expecting the coronal hole high-speed stream to show up late tomorrow night. I'm expecting it early tomorrow, at least the density portion of the coronal hole high-speed stream. Next, the past 4 hours of Earth's magnetic moment from the ground. And if we've increased the pace on today's video, it's because we are coming at you a little bit late. So we're going to blast through the data pretty quickly here. It will not have an effect on the aesthetics of the fantastic solar imagery that we show you. This is the past 4 hours of Earth's magnetic moment from space, which have been calm. No solar storms have been showing up. And we're not expecting any major upticks either. That coronal hole high-speed stream will be lucky if it causes any geomagnetic unrest. We'll keep you posted. Here's the past 4 hours of Earth's magnetic moment from the ground. And of course, we are known to create more video content if something goes on. This shows magnetic flux density, the units of which are nanotesla. The past 4 hours of Earth's magnetic moment from the ground, again, geomagnetically calm situation is what's going on Earth. It's a KP1. Planetary K index is an average of global geomagnetism. KP1 is the estimated planetary K index. Solar wind here pretty weak. Current conditions are only of 333 kilometers per second. For the solar wind speed, solar wind density less than 2 protons per cubic centimeter. That is pretty diffuse and pretty slow. So when the coronal hole high-speed stream shows up, again, we expect a big density increase followed by a big velocity increase. The density will drop, the velocity will rise. It's what coronal hole high-speed streams do. Next, some magnetic data, starting with the GOES magnetometers. Fairly smooth here. We've seen the last really weak coronal hole high-speed stream subside already. And let's take a look at the top view ecliptic plane field plot. Earth is moving right toward the center portion of the South Pole-oriented current sheet depicted there in red. No changes coming anytime soon to that. We've got a pretty balanced eastern limb there, so we're not expecting any major changes to this sector boundary crossing. You can expect to remain in the South Pole current sheet through tomorrow's daily space weather video. Next, our line of sight field plot. And you'll see that B field fanning out there as Earth moves toward the middle of that South Pole current sheet. Solar radio jets are pointing this way, and here is the line of sight coronal hole plot, which shows those solar radio jets. Were you aware of that coronal holes are effectively solar radio jets? Because the plasma that comes out of there, it does emit some radiation. Anyway, that's our coronal hole line of sight plot. Let's bring up the latest image. And then let's cut to coronal holes. So here is our coronal hole view. And that coronal hole right on the equator there is the one that we are expecting tomorrow to provide a high density solar wind increase. So we'll see a high density wave, we'll see the density wane, and then we'll see the velocity increase around that same time. That is the telltale signature of a coronal hole high-speed stream. There's a great view of a solar radio jet, and these are all South Pole-oriented coronal holes. So this is South Pole. These are South Pole. And again, we can actually expect some more coronal hole high-speed streams, perhaps from those that are rotating in from the east. Next, we'll move to sunspots. And, let's take a look at NASA's forecast real quick. So this is NASA's forecast. And in agreement there, they have the coronal hole modeled pretty weak here. So they're not expecting a very large density wave. But anyway, that's NOAA's forecast for space weather. That was actually NASA's forecast for space weather. And so here's sunspots, and again, 3333 finally got named. It was only there for like 3 days before it got a name. We'll also have 3334 and 3335 will get a name today. That is Again, that's my favorite sunspot to produce a large flare. This one down here. My second favorite would be up here, as those groups set on the northwestern limb. Next, we're going to show some fantastic imagery of sunspots here. So here's the equatorial SDO continuum. So again, we'll have at least one new named group over here. And it is a major sunspot group. So, in fact, both of those sunspot groups there, 3333, which is the one closest to the Earth scale, and the one to its southeast, those are both magnetically complex sunspot groups. And there are large plasma filaments associated with those sunspot groups. That helps increase the probability of coronal mass ejections in many people's opinion as well. So here are those groups in 171 angstroms. And I'd say that's some pretty sweet imagery. What do you think? Let us know in the comments. Nice. So again, the eastern limb is definitely full of activity there. We're witnessing another solar uptick. And you can expect these solar upticks to continue for the next, well, over a year, until we see a significant downtick. In other words, we are not yet at solar maximum. Here's that new group in the northeast. It's a pretty sweet close-up. And you can see that one is somewhat active there. You can see some plasma activity happening there, some minor flaring. And once again, there may be another sunspot still rising to the north of that. You can see more active, bright towering magnetic filamentary loops there, shining around the limb there. So that could be an indication that there are more sunspots behind the limb. Again, just for completeness, don't forget the possibility that we could see a major flare in that northwestern limb also, as those are some decent sunspots there that are setting up there. So, also, by the way, if you haven't seen our recent video featuring Eugene Bagashov, he's recently submitted a paper for peer review about the anisotropy of solar flares, meaning do solar flares appear at a different intensity when viewed from a different viewing angle? Seems kind of important. Anyway, let's move to solar energetic particles. That is in our playlist, the playlist of The Diamond Anvil. Too Hard to Smash, the latest video in that. So check our playlists. That was a fantastic discussion. We talked about all kinds of silly theories on the internet and then some smart theories. So no spikes in the proton flux here despite an overall uptick in the X-ray flux. So the X-ray flux is back to a C-class background level. That is the rising of those sunspots. And, you know, there are certain data that you can look at it and have an idea what's going on without even having to look at the sun. That X-ray background profile coming up to C1.74 as the background X-ray flux, that made me go, there must be new sunspots, and sure enough there are. You can expect that to continue to rise here, as those sunspots are barely in view. And again, there may be some more groups rising, so that's always a good thing. Here's the past 24 hours in 94 plus 131 angstroms. And if somebody's telling you that an inactive sun is scary or that an active sun is scary, I don't know what information they're using to come up with these ridiculous theories. Remember, folks, it's not a theory until it's well vetted in the realm of science. Until then, it's only a hypothesis. And if it's complete nonsense, it's not even a hypothesis. It's a nothing. Here's the equatorial view, and these wavelengths are good at showing flares. These are both species of ionized iron, the 94 and 131 angstroms. So once again, just to reiterate here, the most likely place to see a large flare is down here in the southeast. The second most likely place would be in the, I'm going to say in the northeast. And the third most likely place, so second most likely place for a large flare is up there in the northeast, and the third most likely place for a large flare is in the northwest. And if you're wondering why this is called the east and why this is called the west, it's because space weather rises over here like the east when the sun rises. Sunspots rise over there in the east, and they set over here in the west. That's why it's the east and the west. Anyway, getting back to additional data here, we like to show a star chart as it means something to somebody. And if you're up before dawn, you might see the crescent moon very close to Jupiter up there in the sky. Also Saturn up there on the ecliptic. And if you've got very clear skies, you may even see Mercury if you've got a low horizon, if you are up before dawn. Next, our solar system forecast. This is where heavenly bodies currently are located. That is, besides the ones who aren't viewing this video. I guess they're all right here. Anyway, here's your 1 week solar system forecast as we approach new moon. Here's where things will be on June 21st, which is, by the way, the solstice, and we'll be streaming live for the solstice, so make sure you join us for that. It'll be a YouTube exclusive. Next, we're looking at coronagraphs to see if we've got any coronal mass ejections and if there are any earthly directed ones. The answer is not in yesterday's images. That's 96 frames from yesterday. And here are some frames from today, an additional 30 frames. I don't see any CMEs that are earthly directed, but let's take a look at Soho, Lascaux, C2, and C3 just to make sure. It's been pretty calm here. Pretty calm, and you can expect the likelihood of coronal mass ejections to remain nearly 100%. We'll also show stereo A, and it's all those filaments that we were talking about earlier, which will show you more up-to-date information here on in a moment. Stereo A located over here on the left, and once again looking at Soho, Lascaux, C3 on the right to show not a lot happening. So underperformance in terms of coronal mass ejections, and those underperforming things, statistically they end with coronal mass ejections. So anyway, that's what's going on with coronagraphs. What, you want some custom coronagraphs? You want some 24-hour videos that we took just specifically for people like you to watch? Okay. So there's the past 24 hours. It shows SDO 193 angstroms, Soho, Lascaux, C2 in red, and C3 in blue. So some outflows happening there. Nothing that looks like an Earth-directed coronal mass ejection. If so, it's pretty stealthy. I don't suspect any of that plasma is likely to strike Earth's magnetosphere. Anyway, what's next? Filaments are next. And the El Teide ground-based solar observatory is certainly showing filaments in spades. Or perhaps hearts, diamonds, or clubs. But those are a lot of filaments, especially in the southern hemisphere. I would mainly note, especially this one, which we kind of showed earlier in the video. That one could turn into the next solar polar vortex, as it looks like it's tending to move down toward the south as time goes on. So lots of filaments. Some of them are quite huge. And if you'd like to name filaments after living people, join us over on Twitter. Yeah, Twitter, the completely broken, censorship-rife platform that considers itself some sort of a pioneer in artificial intelligence. What a joke. I mean, the stuff it recommends me is absolutely ridiculous. And yeah, if you want to name filaments over there, I recommend naming this one. In fact, I'm about to name it myself. Just follow the hashtag #NameThatFilament. How about I don't know. I don't know who to name the filament after. Will you name it? You can only do it on Twitter. It's a reason to follow us over there. And if you think free speech has been fixed because of Twitter, then you are not paying attention. We're also on Instagram if you're interested in lots of fitness, lifestyle, diet posts and things like that. Join us over on Instagram. Here's the past couple of hours from the GOES 18 in ionized helium. Wow, major filaments here. I mean, I would recommend naming this one also. Another crown prominence happening up there. And again, you can expect these sorts of things to continue for the next, 2 years. Just keep in mind, folks, that really active solar cycles are shorter in duration, in time period. So grand solar minimum cycles are really long solar cycles. They're like a year longer than a more active cycle. So just so you're aware of that, that does affect things. So the more active the cycle is, the shorter its duration will be. This is a known thing, and it's well documented in the literature. So here's our bonus feature segment, starting out with satellite charging hazards, which are clear. No satellite charging hazards currently going on planet Earth. The GOES electron flux here still in quite low levels. There's the 1-year graph of the relativistic electrons, which are measured at the F layer of the ionosphere, by the way. And there is the NOAA forecast. Just expecting flat levels. I mean, I would expect a little bit lower levels coming down here, but it won't be a major difference. Let's also take a look at the vibrational frequency of the F layer. Feel free to pause the video on this frame if you're not familiar with the information depicted. So there's the F layer, the vibrational frequency in megahertz, millions of vibrations per second. And if that's all Greek to you, don't worry. We'll show the anomalygram, which will be a little bit more clear. So mainly low-frequency anomalies going on here. Nothing major, I don't think. That is anomaly in megahertz from a 30-day median. We show it daily on the channel because you never know when a data set will become relevant to something or perhaps even have predictive value. Anyway, there's a latest image, 1245 universal time ionogram and 1245 universal time anomalygram. We also show the total electron content daily on the channel, as it is another space weather feature that we can easily catalog daily. If you want to know what was going on with it a year ago today, check out our daily space weather videos playlist. They're conveniently right there on YouTube for you. Total electron content is free electrons to about 12,500 miles of altitude, and we do have electrons significantly out of place once again. So some significant high electron content anomalies there around the Antarctic continent, south of the Atlantic Ocean there. Also southern Indian Ocean showing some significant high electron content anomalies. So some electrons there out of place, which is more typical of the low levels of electron flux that we're seeing. So that is what's going on a global scale. Next, we'll show the North American zoom in. And for the sake of time, we only show the anomaly from the 10-day average. So this is the total electron content anomaly from the 10-day average and the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It's depicting electron counts. So this is all the electrons, all the free electrons from ground level up to about 12,500 miles of altitude. That includes the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. So there you go. There is the, and keep in mind this is showing high electron count anomalies in red and low electron count anomalies in blue. So that's the North American total electron content, and we'll close out the space weather section of the video with the latest magnetogram and intensitygram. So these sunspots here, not super complex. They're not super likely to produce large flares, but large flares do seem a little bit more likely at the limb. Read Eugene's paper if you don't believe me. And by the way, we've actually pinned the recent video with Eugene to our profile on YouTube. Let's check out these sunspots briefly. A great view of those. Again, those are quite magnetically complex. This one here is just huge, as it takes up a lot of space. And this one here is, well, they're both beta, gamma, delta class sunspots, which are the most likely to produce large flares. And not being a slouch, I want to see this group up here as well, so let's see that. That sunspot is that one's only alpha class as far as I can tell. So again, there may be another group rising up there above that. At the moment, we don't see any magnetic fields showing up yet. So have to wait and see what happens with that. And let's move to meteorology. I discovered about 15, 20 years ago that it's way too easy to forecast the weather. And so we've decided to include meteorological stuff on these videos. So yeah, it's a value-added service. We used to make them separate from the space weather videos, and guess what that did? It reduced our views on YouTube. So that makes a lot of sense, right? Anyway, what I'm doing to start things out is some wave chasing. The world's largest waves are right off the coast of India there. They're like 43 feet. It's also the windiest place in the world and the lowest pressure. So as that thing makes landfall, you know, the important feature there is sea surface temperature. And you can see there is plenty of hot water around there to aid with convection. It's been loitering, and let's just say the surf's up around the west coast of India. So that's what's going on in terms of waves. And we've got certainly hurricane force winds there. There's a reading of 79 miles an hour. And let's see how the wind blows on the rest of the planet. So there are the surface winds of the east. Here are the jet streams of the east. Central world's jet streams depicted here. Blowing backwards over the central Indian Ocean there. And here are the surface winds of the central world. Surface winds of the west. And these are the jet streams, which have reformed over the U.S., making weather a little bit more normal, at least for the southern half of the country. The northern half still seeing some odd weather patterns, perhaps. Next, our satellite map. This is the past 2 hours from windy.com's glorious satellite map. A large but not particularly strong low pressure continues to dominate the northern Atlantic. And we've got a low pressure there over Ohio as well. You can see that counterclockwise rotation over the eastern U.S. Clouds and fog are next. Shout out to our viewers from South America. There's at least one of them. Thanks for tuning in, Bruce. Bruce Minas of Brazil. Cheers. Anyway, that's clouds and fog over the lower 48. Here's your weather.gov map, and if your location is lit, click your location. We've got some heat advisories and also some severe weather forecasted there for Oklahoma. Some severe thunderstorms forecasted. Also, heat advisories for South Florida, it looks like. Weather.gov is the location for those warnings. And I think some frost advisories for Nevada. How about that? Anyway, let's show our weather forecasts. Here is the pressure and precipitation forecast based on a GFS model for the next 72 hours. And some June snow showing up for Wyoming, it looks like. It's going to be pretty minor, but anyway, that's your pressure and precipitation forecast based on that 72-hour GFS model. Here is your total accumulated precipitation forecast for the same GFS 72-hour model. And we've got some heavy rains forecasted there for Mississippi, Alabama, and Georgia, expecting like 4 inches of rain over large portions of those states. Again, if you're under weather warnings, head to weather.gov to get your weather warnings. We only zoom in so far on the channel typically. Here is your temperature anomaly forecast as well. It's been pretty cool in Pennsylvania, and it's pretty cool over large portions of the country, and anomalously hot over other portions. So this is your GFS 72-hour temperature anomaly forecast in degrees Celsius. We'll also show lightning, which does strike twice, by the way. That's the past about 10 hours, as we saw some heavy storms there stretching from Kansas down into Louisiana, mainly. Some heavy lightning storms there, some significant thunderstorms. And here we've got some current lightning strikes happening there. Memphis, it looks like you're in the crosshairs. Some weather headed your way. Also Fayetteville, seeing a little bit of a thunderstorm happening there. Also some thunder and lightning in Georgia. So that's what's currently going on. Today's featured product is being worn by me. Yeah. For some reason, the face of evil always decides to just show itself, and then people just follow it anyway. That's today's featured product. Tony Fauci, fraudster, face of evil. And it comes in all kinds of different features. In fact, I've got my foot on the bath mat right now. You want to put your feet on Fauci's face every day? Get a Fauci face of evil bath mat. I don't know why people follow the face of evil after it reveals itself so obviously, but they do anyway. I guess because I am the science, right? It's because they believe in science like it's some kind of a religion or a worldview. Pretty ridiculous. Demand accountability, as we do. Tony Fauci, fraudster. He has resigned, however. Remember, there is no statute of limitations on murder. Anyway, here's the homepage that we built back in 2019 in response to pathetic censorship, which did nothing but accelerate since the year 2020. SmashOmash.com, and welcome to the Neo Renaissance. From the official homepage of the Smash News Network, least busted name in news, SmashOmash.com. You can find our links. You can find our forum. You can find our merch, all on the homepage. And by the way, we are real free speech purists, not free speech phonies. We encourage all legal speech. Just keep in mind, if you make an idiot out of yourself, we will not censor you. Yes, if you type ridiculous comments, you may be berated, and nobody will get censored. If you want to support the channel via subscription services, become a member of the Smash Team at smashomash.com/Smash Team. Join at the gold or silver level, especially thanks to our gold and silver level Smash Team members. You're helping us to write a paper explaining a plausible mechanism underlying the solar sunspot cycles. When it passes peer review, it'll just be the most important paper in hundreds of years. No big deal. Thanks again to the Gold and Silver Smash Team members. These videos were brought to you in part by their contributions to our efforts. We're going to close things out with some additional weather data for you here. This is the U.S. Doppler radar map. And let's briefly zoom in on these strong storms. They're moving east-southeast at the moment. We'll focus on the lower 48. We'll show you clouds and fog. And we'll show you water vapor, which should help you out with the physics. Check it out. We have a great impulse here, a great example of a nice dry massive air impulse, which is pushing this system forward as well as creating massive pressure boundaries. It's causing this precipitation in Louisiana. That is an effective low pressure system that is being wringed out by all that dry massive air, which is not only pushing it forward, but it's also helping to sandwich it between this other high pressure system, which is acting like a blocking mechanism. Also, there's an input of cold air pushing down, so there's a lot of compression happening there over Georgia. Atmospheric compression. It's going on. And here's your recap, because we're going off. We showed you Doppler. We showed you clouds and fog. Check out that low right over western Lake Ontario. Actually, it's central Lake Ontario. Anyway, that's where we'll have to shut this thing off and get it onto your screens on YouTube as quickly as possible. Thanks to everybody who's tuned in. Congratulations on realizing the channel exists. And may that solar wind be at your back while I'm back to the bunker. Thank goodness there's a safe place somewhere, and it's the bunker. Bye. Whoa.